Welcome to this codEditor video tutorial. The software codEditor is used to configure OEM-specific diagnostic datasets for the RA consulting software DiagRA. With the codEditor, DiagRA users can easily create and change diagnostic datasets in order to configure the software to their individual specifications. The codEditor is free of charge and can be downloaded from the RA download server using the access provided together with the DiagRA license. To download the setup, please log into the download center and then go to the subdirectory DiagRA MCD Tools. In this folder you can always find the latest version of the codEditor software. After downloading the file, please unzip it and then put the complete folder into the installation directory of your DiagRA software. The configuration tool can be started directly by clicking on the codEditor exe file. A separate installation is not required. The user interface of the codEditor consists of three main areas. The first area is the tree area on the left. This area contains all the different data categories and functions that are included in the currently active dataset. In the beginning, the tree area shows the elements of the most used data types. By clicking on the individual elements, the tree area expands in order to edit the items in the selected category. In order to add new elements to a category, make a right-click on the category name. This opens a context menu in which you can choose whether you would like to add one or multiple elements to the category. In the middle of the user interface is the data area. This area contains the individual elements of the data category selected in the tree view. By clicking on one of the elements, the user can edit it. The lower part of the user interface is the editing area. After selecting an editable element, the editing area adjusts to contain the required fields. Here, the user can edit the configuration of the selected element. Each fault code, measurement value, etc. is represented by an individual element. This allows for a maximum of flexibility in the configuration. After changing the values, it is important to save these changes. This can be done either by clicking on the Apply button in the lower right corner or by using the hotkeys Ctrl-A. The first step in creating a new dataset is configuring the general ECU information. By clicking on the ECU name on the top level of the tree area, the general ECU configuration can be edited. It is important to store the new dataset in the codEini folder in the DiagRA MCD installation directory. Otherwise, the software will not find the dataset. New datasets can be stored in separate folders. The name of the folder will be the name of the dataset, which can be selected in DiagRA. The ECU name is the name which will be displayed in the address word selection of DiagRA. The ECU number is only required for the UDS extended protocol and allows to specify addresses in case the payload of a message contains elements of the message address. The request ID configures the physical address of the ECU in the network, while the response ID configures the physical address of the DiagRA software to which the ECU should send the response. The protocol selection enables the selection of either the UDS, KWP2000 or GM-LAN protocol for the communication with the ECU. Also, the baud rate can be changed if required. If you would like to use the advanced developers functions in DiagRA, it may be necessary to integrate a seed and key file to unlock the communication if required by the ECU. This can be done by including the link to the storage location of the seed and key DLL file and by selecting the appropriate security level. After setting up the ECU itself, it is now possible to edit the elements in the different categories. The category fault codes contains all the DTC configurations. By right-clicking on the category name, the user has the possibility to add single or multiple fault codes, to add OBD fault codes, and to import fault codes from a CSV file. After selecting the desired option, the editing area changes. Each fault code consists of the fault number and the fault description. In DiagRA, the configured DTCs will be displayed in the lower left area of the user interface, which contains all DTC information. The category status bits allows the configuration of the ECU-specific status bits. By right-clicking on the category name, either one or multiple status bits can be edited, as well as a list with the standard status bit configurations. Each status bit can be edited individually, including the activation and deactivation of each bit state. In DiagRA, the status bit information for each detected fault code will be displayed below the corresponding fault code entry. In the category identifications, the upper left part of the DiagRA user interface can be configured. Again, the user has the options to either add single or multiple identifications or to add the standard identifications. Each identification consists of a diagnostic identifier, a short name, and a comment. Additionally, the byte order needs to be set according to the ECU specifications. The last element is the conversion, which defines in which format the values will be displayed in DiagRA. The category measured values is used to configure the measurement values on the right-hand side of the DiagRA software. These are values that will be requested frequently and can therefore be used to monitor and record values over time. The user has again the possibility to either add one or multiple values. Each measurement value consists of a diagnostic identifier, a short name, and a comment. Also, the byte order as well as the length of the value need to be configured. Important for the configuration of a measured value is the conversion. It is possible to display the raw value in various formats or to transform it into a physical value by using a conversion. Also, various types of text table formats are supported. In order to add a new conversion and to assign it to the measured value, click on the New button. All conversions can be edited in the corresponding category in the tree area. Each conversion can be assigned to multiple measurement values. The first step is to select the type of conversion which is to be configured. In this case, we are going to select the linear conversion. Each conversion needs to have a unique name which can be entered here. The value factor represents the number by which the raw value gets multiplied. The value offset represents the number which either gets added or subtracted from the product of raw value and factor. Unit represents the physical unit of the value, and the decimal place defines how many numbers after the comma will be displayed in DiagRA. The area comment displays the whole formula of the conversion after applying the changes to the dataset. After configuring the conversion, it can be assigned to one or more measured values. Additional to the OEM-specific data on the standard page of DiagRA, also the workshop functions of the extended page can be configured using the code editor. By right-clicking on the ECU name, the user has the option to further add session controls, actuator tests, routine controls, and write data elements. After adding any one of these elements to the dataset, they appear as a separate item in the tree area. In DiagRA, all these functions can be found on the extended page, where they will be represented by separate tabs for each function type. For the purpose of this tutorial, we will additionally add an actuator test to the dataset. The configuration of these functions is similar to the configuration of the elements in all the other categories seen before. Each actuator test consists of a diagnostic identifier as well as the short name of the actuator test. In the drop-down menu of the category property, the user can select whether it is a control or an adjustment parameter. The last element required is the comment, which gives the possibility to include a description of the function. Various states of the actuator test can be added by right-clicking on the item in the tree area. After the configuration of the dataset is completed, it is necessary to save the complete dataset. This is done by right-clicking on the ECU name and selecting Save. Now the new dataset can be used in DiagRA. Of course, it is possible to load datasets again into the code editor in order to change configurations or to use them as a basis for generating new datasets. Whole datasets can be given to other DiagRA users by copying the folder of the dataset from one computer into the codEini folder of another DiagRA installation. Each dataset contains configurations for one ECU. For multiple ECU configurations, multiple datasets are required. During editing, multiple datasets can be loaded into the code editor in order to compare them. In DiagRA, it is possible to change between different ECU configurations by selecting the different datasets. You can find more detailed information on the use of codEditor in the included manual of the software. Thank you very much for watching this codEditor video tutorial. If you would like to learn more about the use of this software tool, you can look at our frequent product trainings held at our headquarters in Bruchsal, Germany, or contact us for an on-site customized product training. Trainings are held worldwide and are available in German, English, and Chinese. For further information, please visit our website at www.rac.de or contact us directly.